Hi, my name is Kausar Mukherjee and I'll be presenting you my first tutorial video. And the main reason why I wanted to go for a tutorial was that like almost for the last 14 years I have been serving the computation industry in some form or the other. But what I feel is that I always use my knowledge to either make money for myself or to make money for some corporation. But as a human being, I always believe is that there is some time when you should actually give your knowledge back to the society, because that is also one of the key features that actually differs that actually differentiates us from any other beasts. So the tutorial which I'll be presenting you is about how to build up a distributed machine learning or a distributed deep learning environment for your corporation or for your project or maybe as a product. And and I know while I was making this tutorial, there was a number of people who actually always raised a question that why did I skip all the Python, and why did I skip all of the scikit-learns and TensorFlows and PyTorch and directly jumped into distributed machine learning in building a distributed machine learning platform for the organization. Because many of people thought that it will be better, because when I'm actually explaining you about distributed machine learning, many people pose this question, like they question to me that without making you know the machine learning, what is a normal machine learning is, why did I jump to this directly to this distributed machine learning environment? And my answer for that question is actually, there are two kinds of professionals, what I believe. There are two kinds of approach. It's not about two kinds of professionals, but always in life there are two kinds of approach when you deal with any kind of layered system, because computation is more of is basically a layered. It's not a something like a single piece of thing. It comes in layers. So there are two ways to break this. There's two ways to break this. Okay. So one is like you go either by a bottom up approach. So most of the people when they go about machine learning, so I've seen that they usually go by a bottom up approach, and that is not bad also, because that makes your foundation of machine learning very strong, and that makes you very much apt for setting up a machine learning maybe a pipeline for your company. But there is another approach that is known as a top down approach, in which basically what you do, you actually understand the requirement of the corporation. So the requirement is not something like building up a single machine learning pipeline or something like that. The requirement is it is not only about building up a machine learning project, but it's about transforming your corporation from a normal corporation to a AI corporation. And let me tell you, just writing a it's not my words. It's a word. It's basically a statement of the man I always admired, and he's also one of the reasons why actually I'm going for this tutorial, because that is one of the reasons I always admired the man, and he's none other than Professor Andrew Ng. And probably if I've done anything in machine learning so far in my career, that is like one of the main reasons is has been Professor Andrew Ng. And I have been really moved by the way he gives back his AI knowledge to the society, and that inspired me to make this video tutorial as well, because he's probably one of the most respected uh, figures when I consider in the AI, and I respect him like a guru. He is my AI guru. And there are other few professors as well whom I always has had a lot of respect for them, and one of them is late Professor Patrick Winston. He's also a great engineer. Probably he's one of the greatest engineer I've ever seen in my entire life. And it's very sad that he passed away last year. And I'm really very upset when I heard this news. So anyways, though, so coming back to our topic about distributed machine learning and this top-down approach. So this top-down approach is that something like that. Why I went for this top-down approach, because if I now start explaining you what is a top-down approach, it will sound to be very much alien words, because that we like I'm not still have started, and many of you who are very new to machine learning may find this thing like very tough to understand at the first moment. But I'll simplify it. Why did I follow this distributed machine learning video approach before explaining machine learning? Let me tell you a very simple example. Suppose you are suppose you are in a racetrack and you want to, suppose you are having a car or a bike and you want to go for a race. I know many of you are great riders and great drivers and who actually race sometimes, I know, but though that is not very good for safety purpose, but if you race you should always carry the safety kits, you know. So anyways, so suppose you are racing on a track and you are racing with a so suppose you are racing with a car. As I'm driver, I can explain with a car example of a car. So it's something like that. Say suppose I'm participating in a race and I'm driving a car, say suppose which is of say suppose 150 bhp, and I'm a great driver and I drive the car very well and I shoot up to 120, 140, 140 odd kilometers per hour. But what happens even after being a great driver, even after driving very well, even after trying my best, I shoot up to 150 kilometers per hour, and all of a sudden somebody, say suppose with a 400 bhp odd Audi or a Lamborghini, he shoots past my car and he beats me in the race. So why I brought this analogy is that when you go for a machine learning project, it's very important to see that you have got the right engine, because you may be a great driver, you may drive great, but if you are not having the engine, you cannot win the race. And that is the reason I chose to speak about the infrastructure, the platform, how to build up the platform before you even start looking for doing a machine learning project. And why do I stress on this is because in the last 5 years I've spoken to a number of companies, to numerous companies who are doing machine learning or AI pipelines. And when I ask them only one simple question, is this machine learning pipeline in a POC or this is in production? And trust me, 85% of the cases, their machine learning pipeline is in POC. And like every time they say that next year I'll move this to production, and the next year never comes. And that is because they don't have the engine. Because when you are fitting a machine learning pipeline in a production, you have to look in a number of cases. It's just not you will be given a CSV file and you will just read the file with a pandas.read CSV and start doing a machine learning. Things are not like that in production. So things are coming in streams, because in today's world, when you are saying about machine learning, and you have to understand that where this machine learning gets implemented, it gets implemented in autonomous cars. So these autonomous cars are having cameras in which they are actually capturing these images, and the car is probably running at 140 kilometers an hour, and it is looking at those images and it is predicting those images, and on basis of that prediction it is taking the directions. So you can understand how fast it needs to be. And that means that data that comes to the machine learning inferencing, that is not a normal data. That is not a normal dead CSV that is lying in some odd corner in your hard disk. That is a streaming data. And when you are dealing with streaming data, it's not that every time the stream will be like 100 messages per second. Sometimes it will be 10 messages per second. Sometimes it can be 10,000 messages per second. And if you don't have a scaling architecture, if you don't have a platform in which you can scale, suppose like I have like 4 CPUs and it was running very well for streams which was coming right like 100 messages per second, and it was doing great machine learning inferencing. And the moment those 100 messages went up to 10,000 messages per second, my system breaks. Because why, because I'm not production ready. And that is the reason companies find it very difficult to take their machine learning pipelines from POC to production. And the truth is that most of the companies, I'm not saying it all, there are giants, there are very there are some startups who are doing great. But what I'm telling you about is a general distribution. When it comes to a general distribution, what pipeline is in the production? Linear regression pipeline is in the production because it doesn't need a GPU. But the truth is that going tomorrow, it won't be CPU machine learning anymore, because when I'm telling about machine learning, and this video is mainly about how to set up a deep learning industry level pipeline, and that is scalable, that is like that you can fit in the cloud, that you can fit on premises, and even that you can fit on premises in an environment where there is no access to the internet. Even in I'll say you the example of a kind of one of the use cases that have been told in KubeCon 2019, where the US military fighter jets, those pilots are having visualizations in front of them, and those visualizations are giving the health of the plane, the enemy data from the cameras, from the lidars, and that entire stack is scalable. That entire stack is built on a scalable architecture of Kubernetes. So today, this is a short introduction that I gave. So now we'll be moving to our contents of of this video lecture. So this video will be mainly in 3 parts. In the first part, I'll be explaining you how to build up the platform first. So the first part will be how to set up a Kubernetes cluster using a GPU, because we are trying to build up a machine learning pipeline, rather not machine learning, we are trying to build up a deep learning pipeline. And as we know that a deep learning is basically involved in neural network, which has got a lot of computation, a huge number of bits. So we have to do a lot of matrix multiplication, matrix inverses, and finding out the eigenvalues, eigenvectors. So those kind of metric computations, what they need is tensors, and what they need is like GPU, because GPU you cannot expect a CPU to do the computation as fast, and it will take probably some days or weeks if we use a CPU to do the training or the inference. The training mainly really it is not actually possible on CPU. It's not possible. It's not feasible. It makes no sense to train a single model for 2 days, which you can do in probably in half an hour. So first we'll focus on building up the platform. So for building up a scalable platform, what we'll focus on is a scalable technology, which is cloud native. That means you can have this particular platform deployed in cloud at any point of time. Number 2, it will go very much with AWS. It will go very much with Google Cloud. So that means the existing people who are already using AWS or Google Cloud, it's very easy to migrate. And number 4 is that it is just not cloud native. You can also run it on premises and even without internet connection. That means it can be also used in military grade applications. So the first part of the video will be there'll be 3 topics actually. The first will be how to set up a GPU based Kubernetes cluster, which I'll be describing you right now, just after this topic introduction. The second part will be how to set up a entire Kubeflow cluster on Kubernetes, and I'll explain what is a Kubeflow later on. And the third part will be how will we deploy the different kind of operators like PyTorch operators, serving, Kubeflow serving, and TensorFlow operators on Kubeflow, and how will we make the pipelines of Kubeflow. So with that, we'll go to our first video in which I'll be describing you what is how to set up the Kubernetes on GPU. So before I go to the before I start showing you the commands and start because this will not be just a video, just will not be a video explanation. It will have the end-to-end commands, and I'll also give you my GitHub link in which you can actually go and download the manuals and you can download the codes. So it will be like every command will be typed and you will be seeing the output and how the things are running. So you don't have to worry about that. But before I start in the coding, before I start getting my hands dirty with Kubernetes and start to code, I'll first like to give you an introduction. Like those you already have a knowledge what is Kubernetes is or what a machine learning is, that is fine. So I'll not dig into machine learning right now because today we'll be focusing on how to build up the first base platform, how to build up that scalable cloud native and also on-premises friendly platform that can run in the cloud as well as on-premises. So first I'll be explaining what is why you need a scalable architecture. So as I was telling in that example, suppose like a stream is coming, okay? A stream of data flow is a stream of data is coming. As I explained to you, like one of the classical use cases is say suppose an autonomous car, a Tesla autonomous cars. The cameras and the lidars are fit in the front of the car, and that camera is sensing the different pictures. And say suppose for the time being we forget that we are running any machine learning to identify. Say suppose for the time being we are just taking the pictures and we have to just stream the frames, right? So the thing is that like always the frame rates are not the same. Like sometimes like in the camera the frame rates will be same, but say suppose our IoT data, okay, there are say suppose our data is going and what happens like sometimes say suppose there is some sensors which are sending in feeds, and as these feeds of these sensors they come via radio channels, they come via radio waves, they are using the wave of 2.5 2.4 gigahertz, and those sensors are coming from different sensors of say suppose a factory, and always not all the machines are not working. There are busy times and there are times which are very lazy times in the factory, right? So during the lazy times less number of data is coming in some server, and it is like say suppose you are doing some ETL operation, you are doing just some say suppose some joining operation, you are doing some tables, and what happens in the busy time, suddenly the amount of data goes very high, okay, it goes very peak. So if you are suppose when the lazy time the sensor started, you are having a machine which was having 4 CPUs and the load was coming and it was doing fine. Now suddenly what happened in the busy time, suddenly the load went very high, and as you are doing a real time you cannot have a lot of latency, because in a real time application you always have a SLA for latency. You cannot, like the client always will give you a SLA, so like it should have a minimum, the maximum time in which you are given, you have to show the report in that time. And what happens in the busy time, suddenly the stream suddenly the number of machines come up suddenly, or the machine data gets generated very suddenly because the production is rate is very high, and the amount of stream that gets to your CPU right now, your 4 CPU cannot control that. Now what will you do? Will you stop your stream? Because you cannot stop your stream, right? That is an SLA, because if you stop your stream you are losing the data, and that is violating the SLA. So you cannot stop your stream and get in another machine, and you cannot do that. So what you need is an architecture that is scalable. So as soon as the stream data gets 10 times, so there is a platform which will basically see that the stream data has got 10 times, that is it is coming to a single particular CPU, and the CPU, and I mean to say the single machine which is having 4 CPUs, and suddenly 1 hour before when it was a lazy time, your CPU usage was close to say suppose 30% and your memory usage was close to 35%. And when this data comes in, suddenly in the busy time, the load gets high, the CPU usage strikes to 100% and your memory also goes to 100%. And there is a watcher, okay? So you keep a watcher that watches that, okay, fine, my CPU health is going up. That means if my CPU health is going up, so I will take another machine and fit it to that. So these are very simple explanation. And actually in Kubernetes, you don't actually fit another machine. That has got something to do with IaaS. That is another part of the discussion, which I'll be not coming right now. But say suppose you have got already a set of 200 machines already connected in a LAN, and there is somebody who is watching, and he has, once the load comes, he first gives it to one machine out of the 200 machines, and he sees the CPU usage and the RAM usage, say suppose for the time being. And when the CPU usage goes over 85%, he switches another machine and he breaks the load into two, and the 50% whole load is gives to this machine, and 50% load he gives to that machine. And he sees the CPU usage once again. If it comes down below 50 or something like that, it is okay. But still, if the CPU usage is about 85, then he switches on another machine, breaks the load into three, and schedules it. So Kubernetes is basically this thing, a resource manager. So this is what Kubernetes actually does in layman term. So Kubernetes is basically a resource manager, a distributed resource manager, which you will install in several machines. So once you install a Kubernetes in a machine, that machine becomes a part, like you have to install a machine in Kubernetes in a machine. Then in one of the machines you have to like start the Kubernetes, and you have to add the other machine to the Kubernetes. So you don't have to you have to just install the Kubernetes software, which is a very lightweight software in the machines you need. And the rest of the images and everything Kubernetes will drop from a single place. And that is one of the beauties of Kubernetes. It's a cloud native architecture. So I will dig into that. I'll dig into Kubernetes as well, but not in this video. In this video, I'll first, because this video is not actually concentrating on what Kubernetes is. This video is more of concentrating on how we can exploit Kubernetes to build up a distributed machine learning paradigm. So we'll quickly jump into how to install the Kubernetes, how to get our hands dirty with the necessary Kubernetes command. We'll only use the commands which are necessary for setting up our distributed deployment pipeline. We'll not get into all the details of Kubernetes. But I just wanted to give you a introduction of Kubernetes. So I told about Kubernetes in a very, very layman terms example. But if you look at if you ever become a Kubernetes expert, if you become the Kubernetes or a very very great helmsman, because this word Kubernetes comes from the word Kubernetes, and this Kubernetes is basically a synonym for governor. So that means a Kubernetes expert is basically a governor. He is the governor of the entire enterprise application suite. He's in charge. He is basically the helmsman of the ship. He's basically the captain of the ship who is in charge of the entire application infrastructure and the entire pass. The entire pass is on him. But we will understand Kubernetes from a different angle. We'll understand the basics of Kubernetes. We'll install the Kubernetes. Because Kubernetes is a kind of resource manager. It's not a kind of, it's a resource manager. It is actually more than a resource manager. It is actually, if you see Kubernetes, if you ever become expert in Kubernetes, understand that Kubernetes is basically a kind of distributed operating system. Because in Bill 9, so if you read the standard definition of an operating system according to Bill 9 in Wikipedia, so operating system is something, though I can be, some of the terms I cannot be exactly I don't remember the exact quoted terms of Bill 9, but in very layman's terms, operating system is something about a file system, and it should have a communication protocol, a message passing protocol, a communication and file system is basically what is OS all about. So Kubernetes has both. So in like even your Linux operating system, when you open 10 or 20 notepads, right, it also like allocates you the amount of RAM. It also does some resource allocation. So OS also does resource allocation. Even the OS, normal computers, what it does the resource allocation, the user maintenance, the security maintenance. The same things are done by Kubernetes also, but for a distributed system. So Kubernetes is more than a resource scheduler. It's an OS. It's a distributed operating system. So now, like, we'll cut it short. We'll now move into the how to install Kubernetes right now, and with that, like, I'm ending my introduction and I'm moving quickly to the coding section. Where we'll learn how to install Kubernetes. Now, like, I'll quickly say 4 things about what we'll learn in this particular coding video. So in this video, we'll learn first, before we can install Kubernetes, first what we have to install is basically a Docker. So like I thought that I'll be moving to the coding video, but I think I need to speak for 2 minutes more. So there are 4 things we'll learn. First, we'll learn how to install Docker. I'll just explain you in layman terms what a Docker is. Number 2, we'll learn number 2 is Kubernetes, how to install Kubernetes. Number 3 is we'll understand how to install the NVIDIA Docker runtime. And number 4, we'll understand how to install the Kubernetes daemon for NVIDIA. So these are the 4 things we'll learn in this particular video. And these are the 4 things. So I'll just quickly come what the Docker is. So like many of you in this industry, I'm quite sure, not many, probably all of you have worked with VMs in some time or the other in your life. So VM is basically a virtual machine that you know. So basically you have a machine in which, basically what is a machine? Machine is basically when you say suppose your laptop. Your laptop is basically having one, say suppose 16 MB of RAM and say suppose 4 CPUs and 100 GB of hard disk. So this is one machine. So now what happens? This RAM, GPU and hard disk, basically if you see from another point, this operating system is also a namespace, a kind of namespace thing. That means all these things are basically connected to a single namespace. Now you get an Oracle VM, say suppose. You install an Oracle VM and you give it 2 CPUs. And out of 16 MB of RAM, you give it 4 MB of RAM. And out of say suppose 100 GB of hard disk, you give it 20 GB of hard disk. And you run that. At the same time, your OS is also running, that OS is also running. Right? But it is having a different, like it is sharing your hardware. That means a VM is basically a kind of namespace. You are mapping your 2 CPUs, 20 GB of hard disk and 4 GB of RAM to a namespace, which is basically the VM. Okay. Now Docker is more or less same like the VM, but it is a lighter weight VM because VM always works on processor level. So when you give a CPU to a VM, that means you give your entire CPU to VM. So if you look at your machine, you will like if you go to Windows or Linux, whatever you are having, you will find that your machines will be having, say suppose Intel i5, or say suppose you are having a Xeon processor. So say suppose in a Xeon processor there are 8 cores, okay, and there are 16 V cores. So now when you install a VM, you have to allocate it the V core level. Okay, so that makes it very heavy. It actually works on the CPU, and the Docker is basically a VM, but it works on threads because threads are a lighter part of processor. So your processor, if your V core is basically a heavier thing, a thread is a lighter part of V core. Okay, so Docker is a lightweight VM, you can tell. Okay. Number 2, Kubernetes. I have already told you what is Kubernetes. I have already given a very layman understanding. That is not a very expert understanding, but layman understanding, just you can understand before jumping into things. Number three is that what is that NVIDIA Docker runtime for Kubernetes? So what happens, as I told you, we are building Kubernetes, we are building the Kubernetes for only one reason. We want to build up our analytics, distributed machine learning, distributed ETL stack, which is cloud friendly as well as on-premises friendly. So deep learning cannot run without GPU, as you know. Like it cannot run with GPU, but it is not very useful to run without GPU. So we have to some way make Kubernetes use our GPUs. Okay, and for that I'll be showing you the demo as well, because my own cloud server has got 2 GPUs. Actually, I have got 3 GPUs as of now, but one of the machines have been like one of my machines has got a motherboard crash. That's why it is off right now. So right now the Kubernetes you will be seeing will be on a single machine, though it is having 2 processors. So it is having almost close to 32 vCores. It is having a double Xeon and almost 128 gigs of RAM. So test wise it won't be very tough. And I am having 2 GPUs in that machine currently to show you the distributed GPU sharing example of Kubernetes, and which is a very new thing. Actually, it's a very cutting edge thing. How we can in Kubernetes you can actually schedule 2 pods, one on GPU 1 and other on GPU 2. Okay, so our Docker, whenever you schedule something in Kubernetes you call it pod. So this is one. So what happens for our deep learning pipeline, we have to basically make Kubernetes use of GPU. And before we can make Kubernetes use of GPU, we have to, because Kubernetes runs a container. Okay, so you have to first like make that container is nothing but a VM. So in our case, Kubernetes will be running our Docker container. So before we can like let our Kubernetes use the GPU, what we have to do, we have to first make a NVIDIA, like we have to first make that Docker, we have to first like install that particular API, install that particular applications in Docker, which will enable the Docker to make use of GPU use of GPU as a resource. So that will be basically the NVIDIA Docker runtime, which I'll also show you on hand on my GPUs. And after that, once that Docker is ready, we have to just like enable the Kubernetes daemon set for GPU. Once you enable that, you can run any GPU based application on top of Kubernetes. So with this, I'll switch on to the coding video, where I'll be showing you end to end from Docker installation to what version of Docker you need to install, to what version of Kubernetes, how to install everything. So let's start. Let's dive into that. Thank you, and enjoy the video.